Hello everyone. I want to explain one of the most famous pattern in the coding and its name is two pointers. So I will start with explaining what is the two pointer approach and then I will solve three different examples to explain this concept. Overall, the two pointer approach is a very simple and efficient technique used to solve problems involving linear data structures like arrays, strings, or linked lists. It usually involves using two pointers or indices to traverse or process the data structure. These pointers typically move in a coordinated way, either toward each other in the same direction or even independently based on the problem's needs. Based on the nature of the problem that we want to solve, maybe one pointer starts from the beginning of the data structure and the other starts from the end, and these two pointer moving toward the middle, or maybe two pointer starts at index 0, and then based on the condition of the problem they move until the end of the array. So moving these two pointer is totally depend on the problem that we want to solve. So here, the first example that I want to explain is a question that is very famous in the area of the coding, and it has different variation. So here is a here is the most simple one. The question says write a function that takes a string s as an input and determines whether or not it is a palindrome. So what is the palindrome? Palindrome is a word or phrase or sequence of characters that reads the same backward as forward. We have two examples here. The first example is taco cat, and we can see that if we read from the first index and the last index and move to the middle, we can see that all of the word is same as each other. So the first one with the last one are T, the next one is A, and the next one is C. And we can see that we have one O in the middle, and O, if we write from left or right, is O, is same as each other. So if we have a word B or A instead of O, again, this string is a palindrome. But in the next example, we can see that if we read from forward and backward, we will reach to character C and D, and they are not same as each other. So we should return false in this example. So how we should solve this problem? We we have multiple methods to solve this. For example, we can reverse the string and then compare the string with its reverse. But the problem with that solution is that we need an space to save the reverse of the string. But with two pointers approach, we can put one pointer at the first index and one pointer at the last index, and then we compare these two pointer at each index, and if we found any character that are not same as each other, we can return false. So in this scenario, we don't need any extra space. We only traverse the string one time, and it's pretty efficient here. So let's go to file that we want to explain. And since we want to compare each character from forward reading and backward reading, we can use two pointer. I call them left and right. And initially they set to 0, and the right is set to the last index that we have. So we have these two index. We compare these two index. If the character at index left equal to character at index right, we can decrease this index and increase this index. And if they are not same as each other, we can return false. So right now these two are T. So T is equal to T. We decrement right by 1 and we increment the left by 1. So these two move toward the middle of the string. So right now we are here, and at this point, we can see that again, here is A and A equal to A. So again, we decrease this value and we increase this index here. And then here again, we can see that here is C equal to C. We decrease this and increase this, and we reach to the last character that we have. And here these two index are same as each other, and we can return true since we reach to end of the array, or we reach to the middle of the array, and we didn't find any character that are not same as each other, so we can return true here. We have another example here. Let's see this one. We can see here at the first again, we set the left pointer as 0, right pointer as the last character that we have here. We compare these two value, A equal to A, so we move these two pointer to each other, and then we reach to the next character here, again B equal to B, and that's fine. We move our pointers to each other, and we reach to two different characters, that C is not equal to D, and here our loop should be break and we should return false. Okay, so that's the solution for this question. And what is the time and space complexity here? The time complexity, since we only move our pointer from end until the middle and from left until the middle, we can say that is O of n divided by 2, which n is the number of the character in our string, and we can say that is O of n, since this 2 is not important at all here. And for the space complexity, we don't save anything here, and we only have two pointers left and right, and this 2 is O of 1. Okay, for the code, we can define a function and we call it is palindrome. Our input is S, and if we don't have any S here, we definitely should return true. And as I said, we assign a left pointer as 0 and a right pointer as the last index that we have, and we use a while loop and move the left to right and right to left until they meet each other. So we can say that while left is less than or equal to the right, we compare the value at these two index. So we can say that if the value at index left is not equal to the value at index right, we return false here. And if these two value or two character are same as each other, we move our pointer. We add 1 to our left and we decrement the right pointer by 1. And if we check all of these indexes and we didn't find any character that are not same as each other, we return true by end of the code. So that's it. Overall, the time complexity is O of n, and the space complexity is O of 1. The next question that I want to solve with two pointer approach is question 283, move zeros. The question says that given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. Here we have two examples. Example 1, we have 0, 1, 0, 3, 12, and we can see in this example that we should move the 2, 0 at the end of the array and keep the non-zero value at the first part of the array, and also we should maintain the order of the non-zero element same as the original array. So to solve this, we can use two pointer approach, and as I already mentioned that in the two pointer approach, the initial value of the pointer is totally dependent on the problem that we want to solve. Here, the two pointer initially set to 0. and let's call this two pointer as P1 and P2. So P2 will go through all of the elements in the array, and P1 will keep track of the position where the next non-zero element should go. Keep track of the next non-zero element. Okay, so the way that we want to solve is that we will increase the P2 from 0 and will go forward. And each time that the value at pointer 2 is not 0, we should swap with the previous one. So here, when P2 is 1, the value at P1 is 0, and we swap these two to each other. So we move 1 to index 0 and 0 to index 1. And if the value at pointer 2 is 0, we don't need to do anything. So let's go to this example in more detail. Here is the example 1, and we are using two pointer 1 and pointer 2, and at first we set this two pointer to 0, and pointer 2 should go until the last value in our array, and pointer 1 will keep track of the position where the next non-zero element should go. Okay, so we are moving P2 until the last element here in our array, and then every time that the value for pointer 2 is not 0, we swap the value at pointer 1 and pointer 2. So here at the first step, P1 is 0, P2 is 0, and then we move P2 by 1. Here is the first example that we have. At the first step, we set P1 to 0, P2 to 0, and P2 will traverse the array, and P1 will keep track of the position where the next non-zero element should go. So, I mean, here at this point, we increase P2 until the last index that we have, and each time that the value at index P2 is non-zero, we swap the value at index P1 with the value at index P2. So, for example, here, the value at P2 is non-zero, and the value at P1 is 0. So we swap the value 1 with 0, and this convert to 1, 0. And then we move P1 to here and P2 to here. So in the next step, our pointer is same as this. So at this point, the value at pointer 2 is 0, the value at pointer 1 is 0, we do not anything, and then the only change that we will do is to increase the pointer 2 to right. And here we can see that the value at pointer 2 is non-zero, and value at pointer P1 is 0 yet. So we swap these two value, and this convert to 3, and this is 0. And again, we increase the P1 here and P2 to here. Okay, so in the next step, this is P1 and this is P2. Again, at P2, we can see that the value at P2 is non-zero, the value at P1 is 0. So we swap these two and increase P1. So this is 12 and this is 0. So by this technique, we can see that we set these three value at first, and we keep their order, and we put the 2, 0 value in our array at the end of the array. And by doing this, our time complexity is only O of n, which n is the length of the array that we have, since we only traverse the array one time. And space complexity is O of 1, since we only have two pointer and we don't save anything in an extra space. We can set two pointer P1 as 0 and also p2 is 0. So we can set here p2 is 0, and then we can move through the array for p2 in range of noms. As I said before, we only check the value at the second pointer. So if the value at second pointer is a not 0 value, we should swap, and if the value at p2 is 0, we do not do anything. So here I can remove this, and I only work with the condition that if the value at p2 is not 0. So if the value at p2 is not 0, we swap the value at p1 and at p2 to p2 and p1. So for swapping the element in Python, we can use this one line code, but I'm pretty sure that there are some methods in the other language that you are writing. So the only thing is that we should swap these two value. And then don't forget to increase the p1 pointer. So since we are increasing the pointer 2 with a for loop, here we have to increase the pointer p1 by 1 for each time that we found a non-zero element at p2. So since we did this in place, we don't need to return anything here, and the output of the function is the noms. And as I said before, time complexity is O of n, since we only traverse the array one time, where n is the length of the array, and the space complexity is O of 1, since we did not save anything here, only 2 pointer. And as you can see here, it can work for all of the test cases in the lead code. The next question that I want to explain with two-pointer approach is question twosum 2, which in this question the input array is sorted. The question says that given a one index array of integer numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be number index 1 and number index 2, where index 1 and index 2 is between 1 and the length of the input array. Return the indices of the two number index 1 and index 2 added by 1 as an integer array index 1 and index 2 of length 2. The tests are generated such that there is exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. Here we have two examples, and we can see the array is sorted, and we have two numbers here, 2 and 7, that sum of these two numbers are equal to our target, that is 9. And we should return the index of these two numbers plus 1, which is 0 plus 1 and 1 plus 1. And also we have the other example as below, example 2 and 3. So we already discussed the first question, twosum, and in that question we provide different solutions like hash map approach or the brute force approach. Definitely we can use the brute force approach here, but the problem with this solution is that the time complexity of the brute force approach is O of n2, and space complexity is O of 1. And for the hash map approach, the question mentioned that our solution must use only constant extra space, so we cannot use hash map approach here. Since our array is sorted here, we can use the two-pointer approach, and using the features of the two-pointer approach we can find the target. Here is our example, and our target is 5, and our array is sorted same as this figure. We can use two-pointer approach here, and we set the left pointer to 0 and the right pointer to the last index that we have. And at each time, we add the value at index left and the value at index right. And if we find that the summation at index left and index right is equal to the target, we return their indexes. If the summation of those two values are not equal to the target, we should move the left pointer or the right pointer. So let's go with the first one. Here the summation of the left and right is minus 10 plus 12, that is 2. So we have 2 here, we should reach to 5. If we decrease the right pointer to 7, then we have minus 10 plus 7, that is minus 3. And if we increase the left pointer, we have minus 3 plus 12, that is 9. Okay, so we can see that here, if we decrease the right pointer, we cannot reach to the target at all. From these summations, we can see that if we decrease the right pointer, we cannot reach to the target at all at this case. So since the summation of the value at right and left indices is less than 5, so we should increase this summation. And since our array is sorted, we should increase one of the number at this 2 pointer. So if we decrease the right pointer, we move to 7, which we decrease the summation of these two. And if we move the left pointer, we move to minus 3, which is we increase the summation of the value at this 2 pointer. So since we want to go to reach to this 5, when the summation of two indexes is less than our target, we move the left one, and if the summation of the value at these two index is greater than target, we move the right pointer. So at this time, we have these two value that we already calculate the summation of this 2 pointer, which is 9, which is minus 3 plus 12, which is 9. 9 is greater than 5. We move the right pointer here. So at these two indices, we have minus 3 plus 7, that is 4. 4 is less than 5. So we move the left pointer here. And at this point, we have 0 plus 7, that is 7, which is greater than 5. So we move the right pointer here. And at these two indices, we have 0 plus 4, which is 4. 4 is less than 5. So we move our left pointer. And here we can see that the value at index left plus the value at index right is equal to 5. That is equal to our target. And we return these two index and right plus 1. So we can see that we only move these 2 pointer from the end of the array and from here toward each other, and we only traverse the array one time. So our time complexity is O of n, which n is the length of the array, and our space complexity is O of 1, since we didn't use any extra space here. We only have this 2 pointer, and this 2 pointer is O of 1. So this is the most optimal way for this question. For the coding, as we discussed, we set the left pointer as 0, the right pointer as the last values in our array. We can use a while loop and set the condition when left is less than right, and at each time we have a value at left, which is numbers of left. We have value at right, which is numbers at index right, and we can calculate these two number, which is value at left plus value at right, based on the condition that we already discussed. If sum of these two equal to the target, we can return the left index +1 and the right index +1. So I don't know why they said this question in this way, but we have to do that, since we can see here they add 1 to the index, and yeah, they already mentioned added by 1 as an integer array, index 1 and index 2. And if the summation of these two numbers is less than target, we increase the left pointer, and if the summation of these two numbers is greater than target, we decrease this question, and we can see that it works. And as we already discussed the time and the space complexity, the time complexity is O of n, since we only traverse the array one time, and n is the length and n is the length of the array, and the space complexity is O of 1, since we didn't use any extra space here. Okay, so let's write it this way. That's it.